ବଲେ ଜଣା ନାଇଁ ପଡେ ତୋର ବ୍ୟାକଗ୍ରାଉଣ୍ଡ ଗାଁ ଅଛି। ନା ମୋର ଦେଖଉଛି ଯେ ହେଲେ
Am I audible? Hello?
Yes, sir.
Okay. So this is the 27th Shiksha and Anushandan Fortnightly Academic Lecture, and today's oration will be given by Dr. Engineer Shubhendu Patnaik, who is the Deputy Director of Pathanamtha Planetarium. So I have the privilege of introducing him. Okay, just. So Shubhendu Patnaik passed his 10th and plus 2 science from DM School, Bhubaneswar. year 1988. At that time, he was a popular cricket player in the local area and represented University and Puri district in cricket consecutively for 4 years. He joined in Patani Samanta Planetarium in September 1988 and presently working as Deputy Director Technical in the planetarium. His interest and passion towards astronomy lead him to pursue PhD related to astronomy and he was PhD degree in physics during the year 2013. He has taken part in many state, national, and international level seminars, symposiums, and published many research papers in reputed journals. He is a popular science writer and speaker. Many popular articles have been published by him in Odia and English newspapers, as well as in science magazines. An Odia book, Paraga, written by him, is published on 21st June 2020. He has a passion for popularization of science from his childhood during his service for inspiring young students. During his service, he has traveled all over Odisha to deliver popular lectures and audiovisual shows. He is a popular scientist in the electronic media. Many TV and radio programs were conducted by him to irradiate superstitions associated with village student community. Here and if Sikha and Anusandhan friend. So with these words, I again is very, very relevant, the joy of sky watching. So over to Dr. Subhendu Patnaik. Sir, please.
Thank you, sir. Am I audible? Hello. Thank you, Dr. Nachiketa.
Yes, sir.
Yes, thank you.
Yes, sir, you are audible.
Yeah, I'm now finding my video not coming up, I think. Can you see me?
No, sir.
Okay, just
No,
I'll
sir.
restart it. Give me 1 minute. Yeah,
Your skill.
I'm restarting it again. I'll join back again. Just give me 1 minute. Okay.
So please have patience. Actually, he has some little amount of trouble in sharing in the computers. So just have little patience. Now you can share the data.
Yes, sorry for the interruption. Thank you, Dr. Nachiketa, for nice introduction. Right now, we'll start the proceeding. I'll request all the participants who are there. They can pin myself so that they can see the total slide. I'm not going to share my screen, but I'll. Sky watching. That is the topic I'll explain to you. I think you can see my screen also right now. The joy of sky watching. Just somebody.
And all others, all others, please.
Everybody should mute their ear and they can pin myself so that they can directly see the slides. Thank you. So today's topic is the joy of sky watching. See, as all of us are eager to know about stars, planets, all those things. Basically, today I'm going to give some introduction about sky watching, what is sky watching, when it began, how it began, about all those things. And the sky watching is really a beautiful hobby, I would say. And it started long back. And the sky watching must be the initial stages of opening up of the astronomy or starting of the astronomy. And astronomy, which is the subject deals with sky, stars, planet, is the oldest science, I would say. And this oldest science started when the human beings are living in jungles and in other places. So this is the science which has given birth to all other sciences. Astronomy is the first science, we would say, and that all started with the sky watching. And as topic says you that it's a joy of sky watching. Is it sky watching so joyful? So do you really enjoy watching skies? All those things we'll discuss today. I'll give you a brief note about how to see the sky, how to watch the sky, what are the objects we can see in the sky, and some basic facts and figures. Some of you must be maybe knowing those facts and figures, but I'll just want to repeat it so that if you are really interested in sky watching, we can start, you can go ahead, proceed ahead, and we can have another sessions or similar sessions, series of sessions, so that we'll go a little bit slowly higher and higher sky watching things. So when we talk about the sky, what is the really sky is? If I ask you, you'll just answer it. Is the sky what we see above our head? So to be precise, what's in the sky? We start from very basic. We can see, birds are flying. Into two sections, we can say. And what we are now seeing, or what we are observing, is the same sky which our ancestors were observing for thousands and thousands of years. And all this, by this sheer sky watching, we have learned lot about our universe. If we stop watching the sky nowadays, what people are doing, because our sky is full of pollution, light pollution, dust pollution, and there are other pollutions. So people or students are now glued to the television or mobile phones or computers or laptops. But sky watching is really interesting and a very vast subject, I would say. And I would like to request everybody to watch the sky whenever and wherever it is possible. And if you are really interested to watch the sky, you have to go out of town.
Actually, sir, your voice is not audible. So there is a lot of glitch in your voice.
Glitch. Okay, I'll just. Is it okay now? Hello. Is it okay now?
Not. Yes, sir. It is okay.
Okay now?
Yes, sir.
Okay, thank you.
Yes, sir, it is okay.
Yeah, thank you. So, if you are in sky watching, you have to go little away from your city lights, and you need not have to have any special equipments at the initial stages. And the best equipment you have with you already, that is the pair of eyes. Your eyes are the most sophisticated and beautiful instrument through which you can watch the sky and learn a lot of things about the sky. So let's start today's proceeding. What do you mean by sky watching actually? If you look overhead, in the daytime, we only see one bright object, that is our sun, which rises in east and sets in the west. Every day we are seeing that. And the same thing had been observed for thousands and thousands of years by our ancestors. So if people or a person who is watching this for a long time, he must have asked himself, why this is happening every day? And when we go to the next half, that is a night sky, day and night was a concept that is generated or must have been conceived by our ancestors by watching the regularity of the movement of sun, stars for thousands and thousands of years. In the ancient time, people are watching the sky with their naked eye, and they are seeing that at a regular interval. That time there is no concept of time also. At a regular interval, the things are becoming bright and they can easily see. And after some time, it is becoming dark and they are not able to see. So the concept of day and night started from there. This we also know, but they wanted to answer the question why this is happening, and what they are seeing was that Every day there is a bright object. They named it as a sun, and that is coming out from a particular direction, and they name it as a east. And it is going after in regular interval in the west. So direction, time, night, day, everything started from observing the sky, that is watching the sky, or night and day sky, we can day, night, everything. And what they have observed, what they have seen for thousands of years, is that the whole sky, which is a hemisphere or is a bowl, we can say, just hanging over our head, and there are a lot of teeny dots or dot of light, or they call it stars. So whenever we see some pattern stars, we try to figure out patterns also. And what that is the same thing what the people did in the ancient time. So they started imagining some patterns, and the patterns were different for different for different set of civilizations. The same set of stars, which we know as a Saptarshi Mandal, there's a question mark, we can say inverted question mark. That is imagined to be of 7 rishis in our Hindu culture, whereas the same set of 7 stars were imagined as Ursa Major in other culture, and some culture they see as a plow or a wagon. So people, after watching the sky for long and long years, they imagine different shapes, different size, and related those stars, planets with various stories. There are a lot of interesting stories. If you are really interested, you can see that why this is called a Orion, why this is called Saptarshi. There are a lot of stories in each and every culture. I'm not going to give you detail in today's talk, but there is a beautiful constellation which is called Orion constellation, which you can see tonight. If you are really interested, you go out, and for next 1 month or so, or maybe 2 months, this Orion constellation you can see overhead in the evening time. This is a beautiful constellation which is a part of a story, which is it is imagined to be a hunter, which is the most bright constellation in our night sky, we can say. And you can see this constellation in the night sky. And there is a lot of story associated with this constellations. So people imagine different constellations or different shapes. They name it as a constellations. There are swan, there are dog, there are Leo, there are zodiac signs. A lot of things were imagined and written down or unwritten also. The story goes on and like that. And it is different for different civilization, not same or everywhere, but people imagine the same thing. But one most important thing, which is very common to almost all the civilization, is that the sign of zodiac constellations. You must be knowing that there are 12 zodiac constellations that have been observed by almost all the civilizations. The reason I will be discussing why there is only 12 constellations or zodiac constellations, that I will discuss in detail in later stages. So giving all these data is because I want to give you some input so that we'll enjoy watching the sky. If you're really interested, you can watch the sky. So people of different civilizations, different constellations, they imagine different constellations. As you can see, they divided this whole sky into different pictures, shapes, sizes, and they name it different constellations. But when the modern astronomy started, we divided the whole sky into 12 constellations, 88 constellations. That is, their boundary is fixed and they are named as per our international standards. So now, if you ask, we have 88 constellations, and all these constellations is adopted and approved by throughout the world. So we see this sky. So imagine you are seeing a big ball, half of the ball, and there are stars are there. So these people has observed. And if you observe closely, what you find, there are a lot of discrepancies also we will observe in the sky. What are these discrepancies actually? We have a very common notion, or we always say that the sun rises in the east every day. If I ask anybody, everybody will say that sun rises in the east. But if you look very closely, you will say that sun never rises at the same point every day. And this is a graph, or this is a picture what I have plotted for a year. If you look closely, it's like, looks like a English 8, numerical 8. So the sun sometimes rises at the very bottom in the right side. It goes on in above, and it goes on like this, and again comes back. So that we know that is Uttarayana and Dakhinayana, and sun never rises in the same point every day. That is what our real understanding, or what facts we are told is actually not correct. Sun never rises in the same point and never rises in the exact east. It only twice in the year rises in the exact east direction, and it shifts towards left about 23 degrees, and will shift right towards right, or towards south and towards north. So why this is happening? People try to answer, search for these answers. What we are also seeing these things, but some of us may be knowing that, but most of us don't know that what is the reason for this kind of things. So people try to answer this question, search for answer for these questions, and they try to make stories, try to say facts so that people will believe that this is why we are happening. So they initially people believe that the earth is at the center of our universe, and everything is going around it, which is called a is a heliocentric model, we can see. And if you observe closely in the day sky, you will see that the sun rays are some time of the year is giving us slanting rays, other time it is very vertical. In the summer particularly it is just overhead, and in winter it is little bit tilted. So this gives you the idea why this sun is not going in the same direction every day. So this concept of season came up, and people try to answer the why these seasons are happening. But with geocentric model, the answer could not be given satisfactorily for these seasons. So people gave a lot of things, but which are not accepted with the modern science. I'll just give you some facts which modern science have taught us. And we know that the earth is revolving around its axis. That is, I'm just repeating so that I'll pose some questions to you, so that it will be very interesting. To be precise, it takes about 23 hours and 56 minutes go once across its axis. Similarly, if you we know that it is a day, that is why we call it a day. And what we have actually observing is that sun is rising in the east and setting in the west, which is one day we can say. And but actually this is happening, as we all know, because of our rotation around its axis. Our rotation around its axis, we are seeing these things. So one day is one earth rotation across its axis, and the half of is night and half of is day. And when at the daytime, the earth side faces towards the sun. These are the basic things I'm not going to tell you. And similarly, we have a revolution around its center of sun at the center, which is about 365.25 days. One rotation, which is called a year. And now we know that in modern science, the sun is our center of the earth, center of the solar system, and 8 planets are revolving around this its orbit. And the reason for we are having seasons is that the ecliptic, that means the path which the earth is rotating around the sun, is not a circular one, it is an elliptical one. And when the Earth is actually it is closest to the Earth around January 3rd. Every month, January 3rd is closest, and it is farthest at the on July 4th. 2 dates we can say, and we have a conception that in summer the sun is very close to Earth in the elliptical part, but it is opposite. Since the axis is tilted, we are having the seasons, not because we are close to the suns. So this is what our axis is tilted at 23.5 degree. So the sun rays which are coming to us, giving us, it's falling directly during the summertime. Other in the winter, it is in a slanting. These are very basic things. I don't want to go into details, but what today I want to show is that how beautifully people have imagined, how they have imagined this concept of zodiac symbols. That also we can see if you are really interested. And as you know that the solstice, which is occurs twice in the year, when the Earth axis is tilted farthest and closest. That means it happens only 21st of December or June 20th. These are the 2 dates when we are vertical axis towards the sun. And there are 2 dates which are equinox. That is, the day and night is equal 12 hours, but all other days they are not equal, they are unequal. So these are things we observe actually, and this is because you can see this Earth is moving in a very elliptical path across the sun, and in the December it is very closest, and but the sun rays falls in our hemisphere in a very slanting way. That is why we have winter season that time, and that time the opposite half having the summer season. And in the sky we have another discrepancy, means we don't see the same shape of the moon. If you look closely, of the same size, it changes every day. It changes its shape every day. It's very interesting to observe. If you are you can observe for 2-3 months, you will say that it's changing, and from that changing the size of the moon, you can see say the position of the moon, why this is happening and why this is we are having these shapes. I'm not going to for that details also. This we know that this is happening because the half of the moon is always lighted. I have seen a lot of the students where if I ask why they are seeing the phases of moon, about 70% of the student answer that we are having shadow falling on the moon, but that is not true at all. The phases of the cause of phases of moon is that the position of moon changes from rotates very fast around the Earth, which is about 28 days. So we know that the sunlight is coming from a very far distance, and since moon is a very big sphere, half of the moon is always lighted, and we can see the half position, so that we see the different phases of the moon. And we see beautiful things in the night sky and day sky also. That is called eclipses, lunar eclipses and solar eclipses. That also I'm not going to detail, but we know that whenever 3 bodies, that is sun, moon and earth, comes in a straight line, we have eclipse. And the eclipse can occur, solar eclipse will occur only on new moon days, and lunar eclipse can occur only full moon days. These things all of us know. And I'll again go back to the old concept, how everything began and how they accumulated so much of knowledge from only naked eye observations. What we are seeing is now the sun is rising every day. Similarly, stars are also rising every day. So people imagine or believe that the earth is at our center, and all other things, including sun, is going around the earth, and the stars are at a very far away distance from us. So this is what they imagine, and these stars never change their position, relative positions, I would say. what we are also seeing that, because the shape of constellations remain same for the throughout the year. But if you have observed closely, you must have seen that stars are also rising in the east and going away in the west. So people started imagine things, and what they observed was that, I'll just give you the example. Here is, you can see, now we know that sun is at the center and planets are moving around the earth, at the sun, and there are a lot of stars at a very far away distance. Now imagine the earth is point at position 1, and the, I'll just give it the full, earth is at point number 1, and the Mars, which is revolving outside Earth's orbit, is at point number 1. So if you look from Earth towards Mars, we'll see that the Mars will appear like it is at point 1 in the backdrop of lot of stars, because the stars which are at very far away, they act as a screen. But we know that in 365 days, Earth moves completes one circle around the sun. That means it takes about it moves about 1 degree every day. So after 30 days, Earth moved to point number 2, whereas Mars moved little bit to point number. It takes in 1 month, it has moved a little bit. So when we look towards Mars, we will see that in the backdrop of stars, it has covered a long distance. Similarly, it will go on for in one direction, and after Earth crosses the Mars, it will appear it is going back towards in the backdrop of stars. This is called the retrograde motion of the stars and planets. So these have been observed by our ancestors with their naked eye. So this gave rise to again rethinking why this is happening, and this could not be answered or explained with the Earth at the center. If Earth at the center, everything is moving around it, why we are seeing this kind of retrograde motion of different planets? So they again tried to answer these questions. And again, this retrograde motion or any other motion, I'll just show you here another picture. You imagine we are at January 1 at this position, sun is at the center. If we are looking towards the sun, then it will appear like there is a group of stars which we called it Sagittarius. It is in the line of the Sagittarius. So after 30 days, it moves 30 degrees and it comes to another group of stars which is called Capricorns. Similarly, after 1 month at March 1st, it will look like it is in the Aquarius. So people believe that after 30 days, the sun is moving from one group of stars to another group of stars. So they named this group of stars as zodiac constellations. So the whole sky is 360 degrees, as you know, the circle is 360 degrees, and they divided it into 12 parts. So each part is about 30 degrees. So they 30 degrees, they named it as a constellation, zodiac constellation, or Rasi Chakra. If you know that in Hindi or Odia, we call it Rasi Chakra. So they divided into 12 zodiac constellations, and they believe that what they see also, actually they see, observe also, that the sun appears to be moving from one set of constellations to another set of constellation in 30 days. So we called it Rasi Chalana, or that is from one Sankranti in Hindu mythology. Sun moved from one zodiac constellation to another zodiac constellation, and they named it as a month. So the concept of month started from there only, and that is only with naked eye observations. There are no instruments, nothing there. I'll just explain it a little bit so that it will be easier to understand. Imagine you are at the this point, and there is a red ball. So if I am standing here, the red ball will appear in front of J. So after 1 day, if we move around, it will move 1 degree. So it will appear like it from G, it has moved little bit towards left, towards H. After second day, again it shifts little bit. So after, if we go on increasing days, So after 30 days, I'll see that it will appear to me that this sun has moved from G to H. That means in 30 days, it has moved 30 degree. Similarly, in 2 months or 60 days, it will move from H to I. So this thing they have seen in the sky, and actually they named it as a movement of sun in 12 zodiac constellations. And then they saw that the moon, which is very close to us, we know that moon is about 4 lakhs kilometers from Earth now, and we have landed on the moon also. But what ancient people had observed is that the moon is moving very fast. As we know that moon takes about 30 days to complete one rotation around the Earth. That means every day moon moves around 12 degrees. So in the sky also we observe that. If you look closely, which is very interesting, if you can see, the first day is here, and after next day it will move 12 degrees. That means from A to B, which is 30 degree, it will cover in only 3 or 4 days. It will cover at 12 days. So on 4th day it will be from A to B. Again after 7 days it will from B to C it will come. So if we move for 30 days, it will come back to again same position. So moon appears to moving across the sky every day around 12 degrees. Since it is covering 360 days degrees in 30 days, so 30 into 12 is 360 days. So that is what happening. That is what people observe. So what they saw was that the moon is staying in a set of stars which is about 12 degrees apart. So they named those stars as nakhetras. So from their zodiac constellation, and Narcissus and nakhetras were imagined. So that is what people had seen, and just go back to other thing. So that is how the concept of zodiac symbol, and in our Hindu mythology, nakhetras are developed. And if you observe closely, every day moon stays near one star, which is a bright star, which is called a nakhetra. So there are 27 nakhetras named in our Hindu mythology, and those have been identified by our ancestors, and they have been named by our ancestors also. So that is what people had observed for thousands and thousands years, and they have compiled all those things and in Siddhanta's books. And you can observe the same thing right now and also see that what is happening in the sky. Similarly, we took the case of sun and moon. Similarly, if you look at other 5 planets also, they are changing their positions in the backdrop of sky relatively faster or slower depending upon their position. Now we know that the planets in the order of distance from sun, which is the closest is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We know that we can see only 5 planets with our naked eye, and what has been observed by our ancestors for thousands and thousands of years also. And after seeing all those things, they have developed the concept of day, night, month, year, season, all those things, and zodiac constellations, nakhetras, all those things. And the movement of these stars and planets, particularly planets, bright planets, which can be seen in our naked eye, and they try to predict their position by empirical formulas. This is a very simple thing. If you are really interested, you can do that also. People, as you know that, now we know that Earth is not at the center. The sun is at the center. Mercury is moving around it at the closest distance, and it takes only 88 days to cover take one rotation. And these 5 planets which we can see with our naked eye are Mercury, Venus, Mars, Saturn, and Jupiter. Jupiter and Saturn. And this has been observed by our ancestors. And if you look closely to the names of our weekdays, That is Sunday. Sun is stands for sun, Sunday. Monday is moon, which is can be seen with a naked eye. Tuesday is Buddha, which is also a planet, which can be seen at with a naked eye. Then Venus is Shukra, Guru is Jupiter, which is Brihaspati, and Saturn is Sunny. So these name of our weekdays have also been derived from the naked eye sky observation. So to have a sky observation, we need only few things that I am just going to give you in a brief, so that if you are really interested, we can proceed with those things. First thing is that you need a pair of beautiful eyes, a place where there is no light glare, and if you could have a small telescope and binocular, that is will be very fine. And you have to know about your directions and some sky maps. There are a lot of sky maps, sky charts are available right now. You can print it out, take a print out, and locate like maps, normal maps. You can use sky maps, and there are also very beautiful apps are now available. You can download with a smartphone or with a laptop. Using that, you can detect this position of stars, planet, constellation very easily. So you can find out those things from Play Stores and internet also. I'm not going to give any particular idea, but before taking some questions or answers, I would say few things which are very, very common, but they are not true actually, and they are misnomers, I would say. So, if you ask anybody, sun will have a notion that sun rises every day in the east and set in the west, but which is not actually true, as we know right now. But we are seeing the same thing every day, but never ask this question: what is this? Sun never rises in the east, but it appears to rise in the east, and that is because we are moving around our axis. The earth is moving around that axis, so from west to east, so that we are seeing the sun is moving from east to west. So this misnomer we are so acquainted, so adopted. We never say that earth is moving from west to east so that we are seeing the sun. We say that sun is rising in the east and setting in the west. Similarly, all the stars, what is there in the sky, they also rise in the east and set in the west. To have a sky watch, you must know these few fundamental things. And what is the rate of this rotation or speed of rotation? We know that Earth takes 24 hours to make one complete rotation. So is 360. That means every hour the sun rises about 15 degrees. Suppose at this 6 a.m. it rises. After 1 hour, 7 a.m. it will be 15 degrees above. At 8 a.m. it will be 30 degrees. At 12 noon it will be 90 degrees above the head. And after 6 p.m. it will be in the west horizon. So every hour sun appears to move. I'm again repeating it. It appears to move at a speed of 15 degrees per hour. Similarly, all the stars what we are seeing in the sky appears to move for 15 degrees every hour. Suppose now we see a star at the horizon, eastern horizon. After 1 hour, it will be 15 degrees above the horizon. Again, rise again 4 minutes late every day.
Sir, we are unable to hear your voice.
So,
Yeah. Now it glitch in the net.
Sir, we are unable to hear your voice.
Is it okay now?
Yes, sir.
Yeah, maybe some glitch in your side or my side, I don't know. Okay. This star which you are seeing will rise 4 minutes late every day. That means today, suppose we see a star today's, let's say, January 1st, we see a star at the horizon at 0 degree east. After 1 month, every day it will rise 4 minutes. After 1 month means 30 days, it will rise 2 hours late. That means the same star will appear at 8 p.m. at the eastern horizon. In the again after 1 month, it will be at 10 p.m. So every day the stars appears to rise 4 minutes late. Why this happens? This is because we are moving around the sun also. Apart from our motion across our axis, we are moving around the sun. So every day we are moving 1 degree. So again, coming back to the same sky, it takes 4 minutes more. So that is why all the stars appears to rise 4 minutes late every day. So the star what we have seen on the 1st January at the eastern horizon, after completely one rotation, we will find the same star at the same position. This is how people were predicting the seasons and all those things. The next misnomer is that the sun is a yellow star. What we observe is sun is yellowish or red sometime in color. Isn't it? Everybody knows that, says that sun color is red or yellow. But to be very precise, sun do not have any color. Sunlight is white, bright white light. The color what we are seeing is yellow or red is because of the scattering of light due to our atmosphere. If you go out of our atmosphere or go to moon or go to space, the color of sun is very white and silver light. I mean, white light will bring. Similarly, the most common misnomer is that when you are going for a sky watch, and if I ask you, have you seen a star? Definitely you will say, yes, we have seen stars. And if I ask you, have you seen a pole star? All of some of you or most of you will say that yes, we have seen it. Then how bright it is? If I ask, about 60% of student or 70% of student answered this question as the pole star is the brightest star in our sky, which is the most fundamental misnomer, I will say. Pole star is not the brightest star in our sky. It is not the it will not come within the 10 bright stars of the sky, not even 20, not even 30. It is the 49th brightest star of the sky. That means there are 48 stars which are brighter than our pole star. Pole star is a very dim star. It's very difficult to locate. But to see the pole star, you have to, if you ask the question, you will say that you join the 2 stars of Saptarshi Mandal, you will find the pole star. But if you don't know which is Saptarshi Mandal or Ursa Major, simplest way to locate the pole star is that you must know the latitude of that position, that place from where you want to see the pole star. The latitude of Bhubaneswar is about 20 degree. Bhubaneswar is 20 degree. So you have to face south and look for a star just above the south horizon, 20 degree above. So you'll find a faint star, that is the pole star. If you go to Delhi, the latitude of Delhi is 40 degrees. So you have to look for 40 degree above the horizon. So this means, suppose you are at the equator. We know that we have equator and latitude, longitude. So you go to equator. If you look towards the south, the pole star will appear just at the horizon. And if you start walking towards the pole, you will see that the pole star coming up, and when you just reach the pole, this pole star will be just above your head. That is the 90 degree. That is 90 degree latitude. So this is the how to locate the pole star. Yeah, I have. It's 10 minutes. I'll keep some time for question and answers. Okay, there are a few misnomers are also there, but I'll just go one by one. Then we'll go for some question answers if you have any questions. There is when we look at the sky, we see a lot of stars in the sky. And when we ask how many stars are there, the simplest answer is there are a million of stars are there. But if I ask you how many stars you can see, still you will answer, or most of you answer, that there are millions of stars we can see, but actually we can't see millions of stars. We can count the number of stars what we can see, and in a very clear clear sky and without light pollution, we can see around 3,000 stars with our naked eye. We can't see more than 3,000. So if you are really interested, we can see all the stars, name them and remember them also, because it's very easy and you can see the constellations. So we can see around 3,000 stars with our naked eye. So there are a lot of similar misnomers are there. I am not going to discuss about this, but I'll just have 5, 7, 10 minutes if you want. If you have any doubts till now or any questions or queries, you can ask me, or I'll just say a few things, then we can wind up. I try to keep it within the time. So 10 minutes, the last 10 minutes for question and answers. And if anybody wants any clarification questions or anything, you can just write in chat box, or you can ask me in,
So questions are welcome. If anybody has any doubts or any questions, you please ask. What is the best month and best time for watching the sky?
Yeah, sky watching is for daytime. First thing is that you have to have a clear sky. So rainy season not at all best time, but rainy season is the best time, I would say. Normally people say this is cloudy, but if sometimes we have after a big shower, this you have a clear sky. That time is the most beautiful thing, beautiful time, I would say, because due to rain, the whole atmosphere is get cleaned up, all the dust had settled down. So if you have a chance to look at the sky just after rain and it's clear up, that is the best sky you can see. Otherwise, during September to maybe April is the best time for sky observation. And if you have a place where there is no light glare, that is the best place for the night sky watching.
Sir?
Yes.
Hello, sir.
Yeah.
Sir, in a Raman book, I have seen that he said that we can watch stars with binoculars.
Yes.
Is it really possible, or we will use a telescope?
See, you can see the stars with the naked eye also. You must have seen stars, is not it?
Yes, sir.
To get a little better picture, or you can use a binocular or telescope. But without using a binocular and telescope, if you look at the sky, you can see a lot of constellation shapes. And starting from there, you first have to know the position of some stars, some planets. Then if you after observing those things, you can go a little higher. You can use a binocular or a telescope. Without using a binocular and telescope, also you can see a lot of stars. As I told you, you can see up to 3,000 stars in the naked eye and 5 planets. If you are interested, if you go out today morning, means before sunrise, 1 hour before sunrise, you can see 2 planets, Jupiter and Saturn in the eastern sky morning for next month. After maybe in the month of April, May, you can see 4 planets, so 2 in the evening and 2 in the morning sky. So those things you can see through your naked eye. You need not have to have any binocular or telescope for that. And you can
Sir, suppose I want to see.
Yes.
Sir, I want to see surface of moon clearly. So is it possible through binocular?
Normal binocular will not help you, but there are bigger binoculars or more powerful binoculars. But for to see the surface of moon, you should have a telescope with a diameter of more than 4 inches. That will help you to see the surface of moon, moon's crater, all those things. But with naked eye, you never see craters of the or surface of the moon. And binocular is very difficult to see the surface because it shakes your hand, because binocular do not have any stand. You have to hold it and see. So it shakes. When it shakes, it is difficult to see. But telescope has, if you have a binocular with a stand, then you can, I think you can see a surface of the moon.
Thank you, sir.
Yes.
Another thing
sir,
now
I had
in
a
this, yes, please.
Yes, Bisant.
Yes.
Yeah.
Bisant, you can ask.
Yes, sir. I had a question. Like in modern generation, we're using a lot of different equipments for. Yes, sir. We're using planetary exploration. But sir, how does it differentiate from the ancient era equipments that we're using?
See, first thing is that to see or know more about a star or a planet, first you have to locate it. Suppose you want to see the Jupiter planet. So if you don't know which is Jupiter, which is a star, then to which you will focus your telescope or modern equipment. So for that basic thing, you need your pair of eyes only. You have to locate those things. But still, right now, it do not have to have those things also, because there are a lot of softwares that will take you directly your equipment to that particular object. Like it may be a star, it may be a constellation, whatever it may. You set your coordinates and all those things. It will take. But that is just it will be very mechanical. People in the ancient time, they used to see with the naked eye, and with that observation, they could say which is a planet, which is a star, and how when this planet will move from this star background to other star backgrounds. So if you know that thing, if you start with those things, it will become little easier. And without using any sophisticated instrument, you can know a lot of things and basics also, why this is happening or is happening.
So sir,
Now in
basically
the,
software.
yes, Bisant, yes, continue.
So sir, basically, like in today's generation, the software has played a great role to like improvise and make easy things for us.
Yeah. But to have those softwares, or how these softwares are developed, since the people, ancient people observed, noted down their observations, regular interval of time they are noting down their observations, and basing on those observations, people started back calculating, and devises many theories why this is happening. Initially, people were believing that the geocentric model was there. Then the heliocentric, sun-centric model was developed. So now their concept of elliptical path has come up. So then tilt of our axis. All those things were started only because after the naked eye observation. Then we started developing instrument to recalculate or back calculate those things, and using software computers for those things. But everything started with naked eye observation. That is what I wanted to say.
Got it, sir. Thank you.
Anyone, any question? You can ask me in Hindi, English, or Odia, whatever language you are comfortable. No more questions? Okay, before closing, I just, I think Dr. Sarma has been disconnected. Okay, yes, any question? Bisant, you want to say something?
No, sir. That was pretty much it. So I was actually confused about that. Like, how come we are able to tackle with the modern equipments and from the ancient era to the modern, that the change that has happened. So that was
they took over thousands and thousands of years. We observed the night sky with our naked eye for more than 3,000 years. And during 5th century, Aryabhatta in India, Bhaskara, they observed. But in the 16th century, when Galileo discovered this, prepared this telescope, then we could see actually that other bodies are moving across the planet. Like he first saw that 4 satellite of Jupiter is moving around it. So just a minute. I think Dr. Nachiketa has been disconnected. He had called me. I'll take the call.
Sure, sir.
Okay, I think if you don't have any questions, we can carry on. Before, if he joins back, I'll just I want to say one or two things. Otherwise, we'll close it down. Okay. We have another misnomer that total solar eclipses are very rare. You must have read in paper whenever a solar eclipse comes. We say it's a rare solar eclipse. It's coming after so many years, so all those things. But solar eclipses are not rare actually. It's not right to use a word rare. Rare when it is maybe 100 years, 200 years, or 400 years. But if you look at the record, you will see that every 2.5 years we have a total solar eclipse, and every year we have at least 2 solar eclipses. But we don't see the solar eclipses at the same place. Like at Bhubaneswar, and maybe after 100 years we'll see the total solar eclipse. And so total solar eclipse occurs at a particular place after 350 years. So that is why it appears to be rare. But solar eclipses are not rare at last. If it is coming every 2.5 years, we can call it as a rare. But it is appears to be rare because whenever there is a total solar eclipse, only 1% of the Earth's surface can see the solar eclipse. But whereas in the opposite, in case of a lunar eclipse, 50% of the Earth's surface can see the lunar eclipses. So it appears that lunar eclipses are more and solar eclipses are less. But if you compare, see the data for 100 years, we have around 220 to 30 solar eclipses every 100 years. Similarly, we have 220 to 30 lunar eclipses every year. So they are almost same. But since more than 50% of people can see a lunar eclipse at a time, and whereas it is only 1%, that is why we call it a solar eclipse as a rare. Any other questions or queries if you have? Yeah. Devasit, you have raised a hand. If you want to ask anything, you can
Hello.
ask. Yes.
Good evening, sir.
Yes.
Sir, why does the moon turn red in a total lunar eclipse?
Yes,
So
a
that's
very
what-
interesting question. Moon turns red during a lunar eclipse because when in case of a lunar eclipse, the Earth's shadow falls on the moon. We know that when sun, moon, and Earth comes in a straight line, eclipse occurs, and during a lunar
Yes.
eclipse, the sunlight is blocked by the moon, Earth, and Earth's shadow falls on the moon. But we have a atmosphere. We have a very thin atmosphere. It's about 300 kilometers wide. But what happens? Imagine the Earth is down, and above it there is a atmosphere. So when light comes, it when passes through the atmosphere, it gets scattered. You know that the light is composed of 7 lights, and the red light is least scattered, whereas the blue light, violet light is most scattered. So most of the green, blue, those range scattered in our atmosphere. Only red light passes through our atmosphere and falls on the moon. That is why during a total lunar eclipse, moon turns into red. So sometimes the red moon is called a blood moon or blood red moon during a total lunar eclipse. I think I'm clear.
Yes, sir. Thank you, sir.
Yeah.
I guess there is no other doubts or questions. We guess Professor Nachiketa Sharma sir just got up some technical issues, so he told me to just convey the vote of thanks to everyone.
Yeah.
So Suvendu sir, I think you're also all done for today.
I couldn't get you, Nishant, what you said.
I think sir, you have explained everything so that we can wind up the session now.
Yeah, thank you. Thank you, everybody.
Yeah.
If you are
Okay,
really interested, I'll just share my phone number and yeah. So
yes, sir,
that,
please. That will be really great.
yeah, you can ask me, write me. Just I have said in the screen. I think
Yes, sir.
everybody can see it.
So you can also type down your phone number in the chat section.
Yeah, I'm just reading out 9437 003282. That is my phone number, and my email is sp3282@gmail.com. You can write me, and you can ask me any questions.
Thank you, sir. So
So-
with all of that, I would like to thank Dr. Subhendu, sir. It was a really great session, and you have transferred so many information that we would have never got without your presence. And also, I would like to thank Dr. Nachiketa sir. Because of him, we were able to arrange the session. And with all of that, thanks to all the participants as well. You will be also might be receiving a certificate depending on the feedback link that we have shared. So thank you everyone you have joined. The session is ended now. Thank you.
Thank you very much.